Hi, I'm Kian, and today I want to show you how to solve some multiple choice practice questions from the AP Calculus BCA exam. So I've included 4 questions from previous AP Calculus BCA exam, but I haven't included the answer choices because I want to do it explicitly, and I don't want to you to just guess the answers. I want to show you how you solve each question. So let's dig into the questions. We have the limit as x goes to 1 of x squared minus 1 over sine of pi times x. So honestly, when I see limits in calculus exams, AP exams, I always go for the L'Hopital's rule. But we can check. When we evaluate this limit as x goes to 1, 1 squared is 1, minus 1 is 0, over sine of pi times 1 is a sine of pi, which is 0. So 0 over 0 is indeterminate. So we should use a L'Hopital rule, which states that we should differentiate the top, the numerator, and denominator, and then evaluate the limit as x goes to 1. So differentiating the top, we get 2x using the power rule. And then over differentiating sine of pi times x, we get cosine of pi times x. But don't forget the chain rule. We should multiply by the derivative of inside. So we should multiply by pi. Let me fraction bar. Okay. Now we should evaluate the limit as x goes to 1. So when we evaluate the limit, so for the numerator, 2 times 1 is just 2. And then over cosine of pi is negative 1 times pi, we get 2 over negative pi. So we get 2 over negative pi as our answer. Okay, let's go to the second question. So we're given a position vector which has a x and a y component. The x component is 1 over t, and the y component is e to the power of 3t. So given this position vector, we want to find the velocity vector at t equals 2. So remember, velocity is the first derivative of position. So when you are given a vector or a function for position, like a position function or vector, if they want you to find the velocity, you should differentiate it. So we should differentiate each component of the position vector individually and then evaluate it at t equals 2. So for our answer, so we have 2 components because it's a vector. Differentiating 1 over t using the power rule, we get negative 1 over t squared. Evaluating as at t equals 2, we get negative 1 over 2 squared, which is negative 1 over 4. And then, so we have found the x component of the velocity vector at t equals 2. For finding the y component, we should differentiate e to the power of 3t. Differentiating it, we get e to the power of 3t, but don't forget the chain rule. Multiply by the derivative of 3t, we get 3 times e to the power of 3t. So we get 3 times e to the power of 2 times 3 is just 6. So this is the velocity vector. And we're done with the second question. So we move on to the third question. So in this question, we want to find the slope of a line tangent to the function y equals natural log of 1 minus x at x equals negative 1. So always, when you see tangent, you should go for a derivative. The line tangent to a function or a graph is a derivative of that function. Okay, so we should actually differentiate y equals natural log of 1 minus x with respect to x, and then evaluate it at x equals negative 1. So let me use a different color. So actually y prime is equal to, differentiating that, we get 1 over, actually in the denominator we have 1 minus x, but we don't forget the chain rule. We should multiply by the derivative of inside, which is negative 1. Now we should evaluate this at x is equal to negative 1. So when we evaluate it, we get negative 1 over, and then 1 minus becomes 1 plus. 1 plus 1 is just 2. So the slope of the line tangent to y equals natural log of 1 minus x. At this point, this given point is negative 1 over 2. Okay, we move on to the last question. So we are given if y is equal to x over x plus 1 whole thing to the power of 5, we want to find dy dx. dy dx is another notation for the derivative of y with respect to x. So actually we should differentiate it. So let me write it here. We should find y prime. So y prime is actually, so first of all, we should use the power rule. We bring the power to the front. We get 5 times x over, and then x plus 1. Sorry for the bad handwriting. And then to the power of 4. But don't forget the chain rule. We should multiply by the derivative of inside. But multiplying by the derivative, this requires knowledge of quotient rule. So quotient rule, when we want to differentiate the rational function, we should actually square the denominator. So we get x plus 1 squared. And then in the numerator, we should find the derivative of the numerator, which is 1, times the derivative times the second. We get x plus 1 minus the derivative of x plus 1, which is 1 times x. And when we actually simplify it, we just get 1 for our answer, because x and x cancel, we just get 1. So after simplifying it, we can actually expand x over x plus 1 to the power of 4. We get x to the power of 4 over x plus 1 to the power of 4. So when combining the like terms, we get actually 5 times x to the power of 4, and then over x plus 1 to the power of 6. And that's it for this question. I hope you enjoyed it. Thanks for watching. Please subscribe to my channel, and good luck.